Ready? Okay, let's go. So, okay, so we're going to start with section 1. So chapter 1. And chapter 1 is a lot of basic stuff. So basic stuff, and I think much of it will be review, but we're going to start from the sort of the bottom and work our way up. Some of the ways we describe things or talk about things may be a little bit different from what you've seen before. So I think it's worth making sure that we all have the same basic understanding. Okay. So something very simple to start off with is some notation. Okay, and this is called Bourbaki notation. B-O-U-R-B-A-K-I. Bourbaki notation. If I write, when mathematicians write a fancy-looking n like this, what they mean is the numbers 1, 2, 3, etc. Okay, the so-called natural numbers. Okay, when we write something like, when we write a z, we mean the numbers 0, 1, -1, 2, -2, etc. Right, the integers. Why do we use a z for the integers? It's from the German word for numbers, I think. If you write q, when we write q, we mean the rational numbers. And when we write r, whenever you see an r, funny-looking r like this, it means the real numbers. Okay. Sometimes people start the natural numbers from 0, but for the most part, people start the natural numbers from 1. Okay. The rational numbers. Who can tell me what the rational numbers are? Does anyone know what the rational numbers are? Can somebody describe? Marcella?
Rational numbers include decimals as well.
Include
and fractions.
Decimals and fractions. All decimals. All decimals. For example, like is pi a rational number? So not all decimals. Well, only some decimals. Yeah. So it's some decimals, and does anyone know what decimals turn out to be rational numbers?
Any decimal that can be expressed as two natural numbers, like as a fraction of two natural numbers.
Okay. So yeah. So I think the standard explanation or the standard description of the rationals is the one that Faiz is giving. That the rational numbers are any numbers that can be anything that can be expressed as p over q, where p is p and q are both integers, and q is not 0. Right. So any number of the form p over q. So to write this, what I wrote up here, I'm going to write it in English. It's any number of the form p over q where p and q are integers, and q is non-zero. Okay. So it's a ratio of integers, where the denominator is non-zero. That's why it's called the rational numbers. Okay. Or a quotient, right? A quotient of numbers. That's why where the q comes from. Okay. We said that pi was a real number that wasn't a rational number. Can anyone give me another example of a non-rational and irrational number? I've forgotten your name.
Julia. Square root of 5.
Square root of 5, right? Square root of 5 is not a rational number. Square root of 2 is not a rational number, right? There are lots of numbers that are, in fact, there are many numbers that are irrational numbers. again, if we wanted to be sticklers, maybe I would say, how do you know that the square root of 5 or the square root of 2 is not a rational number? Right? Can you explain? So I don't think we'll do it, but can you explain why the square root of 2 is not rational? Right? In other words, that to be not rational, what does that mean? It means that it's not expressible in this form, right? It's not expressible as a quotient, right? It cannot be expressed as p over q, where p and q are integers and q is non-zero. Can you explain why the square root of 2 is not rational? Okay, yeah, right. So just to give you a little bit of history, at one point in time, people did not. The people's number system at the time of in the time of the ancient Greeks, their number system was entirely based on rational numbers. Okay, for them, what's a number? A number is these things 1, 2, 3, and ratios of them, right? And then at some point they started asking questions, right? If you have a right triangle, and both of the side lengths are 1, well then what's the length of the hypotenuse? What is the right? If this is a number, this length should be some number. Well, what's the ratio that gives you this number, right? What p over q is this, right? What p over q is this thing here? And of course, there is no p over q that works here, because this is actually the square root of 2, right? And so this confounded them very much. I think they called it sort of the undescribable, right? Because it was not, you couldn't find a p over q that described this length here. Right? There was no p over q that described this length, and it really boggled them. There's a story, and I don't know, it's almost undoubtedly false, like a fake story, but there's a story that the first person who showed that it was impossible to describe this length here as p over q was murdered because they were so upset that he had overthrown their system of numbers. Right? They're like, because their system of the world was based on rational numbers. Everything was based on these ratios. Sounds, the planets moving in the sky. Everything. It was almost a spiritual belief to them that everything had to be related to rational numbers. And so when this person, the story goes that when this person showed that there was no p over q for this, they threw him overboard. Okay, that's a story, and I'm pretty sure it's false. But it's a good story, so I'm going to tell it anyway. Don't let the truth get in the way of a good story. That's what my brother always tells me. My brother used to tell the truth a lot, but once he went to college, he decided that he was going to learn how to lie. And so he just started lying to everybody he met. He'd meet strangers, he'd tell them his name was Achilles. Of course his name is not Achilles. Right? And he'd just make up some story to tell them. Yeah. So that's why I learned from my younger brother. Okay, but I'm going to tell you, it's probably a false story. Okay. Okay, so let's go on. Okay, set notation. Okay, so let me just give an example, and this will maybe sort of illustrate what we mean. If I write something like S equals X R such that X squared is less than 2. Okay, so here I have this statement. I'm going to read it in English, right? Let S be the set of real numbers X such that the square of x is less than 2. Okay. Or you could say, not less SB, but or you could say S is the set of real numbers, x in the reals, so x in the real numbers, x in R, x an element of R is how you read this first part, right? X is an element of the real numbers, x is a member, right? X is a member of the real numbers. So we're looking at all x's that are members of the real numbers, such that, so this bar is read such that, and basically it means with the property that, okay, with the property that x squared is less than 2. So that's how you read this sort of thing. Right? S is the set of real numbers whose square is less than 2. Okay. If I wrote, so this thing is an element of, and if you read it with a slash through it, then it's not an element of. It's not an element of. Okay, so for example, if I write the square root of 2 is a real number, right? But the square root of 2 is not a rational number. Right? So just, yeah, that's how people write. The square root of 2 is a real number, but the square root of 2 is not a rational number. Okay. Yeah. So this is basic set notation. What just for curiosity, what is this set? The set of real numbers whose square is less than 2. Can somebody describe it for me? Somebody tell me what it is. Elise?
Maybe on a number line,
Sure.
maybe x would be it would be less than square root of 2.
Less than square root of 2?
Yeah,
Everything?
everything.
So if I had like -10?
No.
No.
So would it stop at 0?
If you stop at 0, that would keep you safe, but that wouldn't be everybody.
Yeah.
For example, if I take -1 and square it, that's still going to be in the set.
Yeah.
What's it going to
It
be?
would stop at
Negative root 2. Yeah.
-2. Yeah,
negative
so
root.
-2.
Good. Negative root 2. Right. So that's the description. This description here is sort of graphically represented like this. Okay. 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 Just for amusement, what if I said something like, what if I changed this to a z? You went to the wrong class. That's all right. Okay. So what if I change this to a z? Then what would the set be? Don't say it. Maybe just take 10 seconds and write down, draw what the set would be. Okay, turn to somebody nearby and say, this is what I drew.
even integer.
Right.
So it could be root 2. No, because it's not equal to
Okay, would somebody like to tell me what this set is?
Here I am.
What is this set? Jennifer? No, the one behind you.
You have a closed circle on
Negative 1, 0, 1. Yeah. So it'll be right. It'll be negative 1, 0, and 1. Right. Right. Because those are the only integers that satisfy this. Right. And you see that they're the only integers that lie within the previous set. Does that make sense? Any questions? What's your name, please? Your name? Yes, you.
Elise.
Elise. What are your two names? What's your name?
Amani.
Amani and Sarah. You're also Sarah.
Yeah.
Right. Okay, so let's go on. So next, sort of fundamental notion that will be very important for us: absolute value. Notion of absolute value. Okay. Notion of absolute value. Right, who can tell me about the absolute value? Like, what does it mean? When I write the absolute value of x, what does that mean? Isaac.
It means that any value that's in there, it doesn't matter if it's positive or negative, is going to be the value that it is if it's like the distance from 0.
The distance from 0. Okay, that's one way of thinking about it. Distance from 0. Distance of x from 0. From 0. Okay. Right. And you were sort of heading in one direction, which was to say that, you know, if I think you were going to say if it's a positive number, then it just stays the same, and if it's a negative number, then it becomes the positive number somehow, right? It becomes then what you get is negative. You get the negative of that negative number. In other words, that positive number. Let me write that out more precisely. Okay. So so this is sort of like a geometric way of describing it. There's an algebraic way of describing it, which is this, and this is maybe the more formal definition, although they're the same thing. The absolute value of x is just x, right? If x is bigger than or equal to 0, right? But if x is less than 0, then the absolute value of x is not x. It will be rather negative x, right? It'll be negative x, right? So, right, if your number is less than 0, right, suppose your number is negative 1, right? The absolute value of negative, if your number is negative 1, it's not going to give you back negative 1, it'll give you back negative whatever you gave it, right? It's a procedure, right? It says, what did you give me? You gave me a negative number. I will return to you negative 1 times the number you gave me. Right? I give you back negative 1 times the number you gave me. Right? Maybe I should use a 2. So if you gave me a negative 2, I'm going to give you back negative 1 times the number you gave me. Right? Okay. So the end result is that it always returns a positive number, and it always returns a non-negative number. It could return a 0. Okay. Okay. So okay. So let's do an example connecting the two things, the set notation and the absolute value. If we consider this set, the real numbers for which the absolute value of x minus 2 is less than or equal to 3. Okay. right? Actually, to make it simple, let's just start with something like this. The absolute value of x is less than 3. Okay. So, just to be very, very dense about it, let's ask, what is this set? What is this set? Okay. What is this set? You say, well, the absolute value of x sort of has two different meanings, right? Depending on where you are. Depending on what number you give it, it could be one thing or another thing, right? So there's sort of two cases. Right, so if x is bigger than 0, absolute value of x is x. If x is less than 0, then the absolute value of x is negative x, right? So so you have to break it into cases, right? Case 1, let's say that x is bigger than 0, right? Then what does it mean? This means, right, for the absolute value of x to be less than 3 means what? What's the absolute value of x? If x is bigger than or equal to 0, absolute value of x is going to be just x itself, right? So it means x is less than or equal to 3. Right. So case 2, absolute value of x less than 3 means what? Negative x is less than 3. In other words, x is bigger than negative 3. Right? So, so what do we get? What is this? What's the set then? Oh, first off, is everybody following what we did here? So what's the set? The set says, well, for the numbers that are bigger than 0, we're gonna look at the guys who are less than or equal to 3, right? So for these guys, we get from 0 to 3, right? These guys are all in the set, right? And then in case 2, we get a bunch of other guys. If we're looking at numbers that are less than 0, then they better be greater than or equal to negative 3, right? So we get these guys. Okay. And so, right, what's the set? Right, the set is going to be, so altogether, so in summary, this set is, everything between negative 3 and positive 3, right? It's just draw graphically, it's from negative 3 to positive 3, inclusive.
If we want to write that algebraically,
Yeah.
we have to do we have to do negative 3, and then is it would be like we would do it in inequality where the x was in the middle and then negative 3 is on the left side and positive 3 is on the right side.
That's right. So this is how you would express it, right? This set is the same thing as the set of x where x lies between negative 3 and positive 3. Okay, let's do another example. The same sort of thing. Let's say that the absolute value of x is bigger than 3. So I'll let you figure it out. Right? Take 2 minutes and figure out what this set is in the same way. So you say, well, we're going to break this into 2 cases, right? Case 1. If x is positive, then this means something. Case 2, If x is negative, then the condition becomes something else. And take 1 minute or 2 minutes. Second? I see.
Is that a comma or is that an equal or greater to, like, either equal or greater than that? Equal than,
Right here?
is that a comma? No, up top, yes. Is that equal to and greater than, or is that?
Greater than or equal to, yeah.
Okay.
Greater than or equal to. Okay, talk to somebody nearby. Turn to somebody nearby and say, this is the set I got.
I'm just going to do this.
Cole, you should move in. Yeah, talk to somebody.
Yeah, I got it. Yeah.
Marcella, are you talking to anybody? I'm sorry, you're not Marcella. Julie, are you talking to anybody?
Yeah. Just kind of short. Say that again. I want to do this down.
Like if you're doing algebra.
No, I mean the
Just like it's not in this word, it's just straight up like this is. Right.
So the second is greater.
Okay, so.
in this case the inequality is saying that all values are greater than.
I think it's the gap.
Okay, okay. Okay, who would like to tell me? Who would like to tell me what you got and how you got it? Would anybody like to say what you got and how you got it? Wait, how about you?
I got -3 is greater than or equal to x, which is greater than or equal to 3.
Huh.
So remember line.
-3 is greater than or equal to x, and x is greater than or equal to 3. So that would say, and it's a little bit troubling, because you'd say that x is bigger than, so x,
No, x is less than.
I'm sorry, x is less than -3, but x is also bigger than 3, right? So you're saying basically that there is no x, right? Because for your x to be less than -3 and bigger than +3. So let's but I can see how that might have happened. So let's take a look, okay? So you say, okay, right, so let's do it. If x is bigger than 0, then the condition becomes, so this becomes just x is bigger than or equal to 3,
Yeah.
right? So what do we get? We're gonna get, for the guys that are bigger than or equal to 0, well, they've got to be bigger than or equal to 3. Okay, so these guys, right? These guys are in. Okay, and then you say, okay, if you're looking at the numbers less than 0, then for this to be greater than 3 means that negative x is bigger than 3. In other words, x is less than or equal to -3. So for these guys, we know that they must all be less than -3, right? So you get these guys. Okay. So the total set is going to be, and you probably had it right, you just expressed it, you just put the expressions together at the end. So what's the set? It's going to be these guys and these guys, right? You can either be here or you could be over here, right? So either x is bigger than 3 or x is less than equal to -3. Okay? And so that's how you'd write it. Okay. If you wrote it together like you did, then it would mean that both of these things have to happen simultaneously, right? Which would mean that there's nothing. Yeah. Okay. Everyone all right? Okay. Okay. So one thing that we're noticing, that suppose we did this with any other positive number a, right? You notice that if we use some other positive number a, then we basically say that, you know, what this means is that you're between negative a and a, right? So if we look at the first example, so in the general case, for any positive a, for x to be less than or equal to a means that x lies between negative a and a. Right? And x bigger than or equal to a means x is bigger than a, or x is less than negative a. Okay. Does that make sense? Anyone confused by this? Anyone have questions? Any questions? Myself? You're right? Good. Julie? Yes. Good. What's your name, please?
Cindy.
Cindy. Yeah. Great. And what's your name?
I'm Becca.
Becca. My sister once apparently memorized like a group of 85 people like within a few minutes. I wish I could do that. Yeah, she was in business school at the time, and they were at this big dinner, and each person got up and stated their names or something like that. And maybe they did it a couple times, and then they said, "Can anyone name everybody?" And apparently my sister got up and just named everybody in the room. Well, you have to deal with her less competent younger brother. Okay, so so one more. We're going to do a couple more examples. So if I say something like this, x minus 2 is less than or equal to 3. X minus 2 is less than or equal to 3. So at this point, you could do this, in exactly the way that we did before, right? You break it up into cases. You say, okay, case 1, if x minus 2 is bigger than 0, then the condition becomes, this thing becomes x minus 2 is less than or equal to 3. In other words, x is less than or equal to 5, right? And then you do the second case, and blah, 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 you put it together. Okay, so that you could do it the way we've done it so far. Okay, could go this way, right? Or you could go a slightly easier route, which would be to say, well, look, x minus 2 being less than or equal to 3 is the same thing as, so this is basically means is equivalent to, is equivalent to what we said over here is that the absolute value of anything being less than something means that that thing lies between the negative and positive that guy, right? So for this thing to be less than 3 means that x minus 2 lies between negative 3 and positive 3, right? Right? The absolute value of blah being less than blah 2 means that the blah lies between negative blah 2 and positive blah 2, right? The absolute value of this thing being less than 3 means that this thing lies between negative 3 and positive 3. Okay, so you'd say, okay, then, so that's the same as saying that x lies between 5 and negative 1. Right? If I add 2 to everything, I add 2 throughout, right? I get that x lies between negative 1 and 5. And you see that we're going to get the same answer as we would have had we done the original amount. Okay. Any questions? Right? And if we right, so pictorially, what is this? This says that x, so here's negative 1, 0, 5, right? So x lies between here and here. X lies between here and here. Okay, there's another way of looking at this. So another perspective. Another perspective. In fact, if you look at the absolute value of x minus y, that's the same thing as the distance between x and y. So there's a geometric way, so this is more geometric perspective. The absolute value of something minus something actually works out to be the distance between those two things. So for example, Isaac said earlier that the absolute value of x is the distance to 0, right? Really, this absolute value of x is the absolute value of x minus 0, right? So you see that it's the distance between x and 0. Right. So there's a kind of nice way of looking at the absolute value of a difference. Okay, so for example, if we look at x minus 2 is less than 3, and we read this, it actually says the distance, so what's this thing on the left? The distance of what from what? Yeah, so what this says in English is the distance of x from 2 is less than or equal to 3. Right? The distance of x from 2 is less than or equal to 3. Okay, so if we were drawing it, we'd say, okay, here's my 2, and I'm allowed to go 3 units away. Right? At the most, I can be here, and in this direction, at the most, I can go down to here. Right? So here's my center, and at most, I'm allowed to wander 3 units away. I can wander 3 units away in this direction, and so this is my set. Right? This is my set. And you see, it's the same set that we got before, algebraically. Isaac.
It doesn't matter that the number is minus 2. It's just
So-
instead of flat.
So x minus y is the distance from x to y. Okay. So if I had something like x plus 2 is less than 3, then to express this as a distance, what kind of a distance is? Can anyone see? This is a little bit slightly tricky. If I wanted to think of this as a distance, this is the distance of x to what? Negative 2. Yeah, this is x minus minus 2, right? So this would say the distance of x from minus 2 is less than or equal to 3, and you get a different set, right? It's negative 2, and this would be between 1 and negative 5, right? That would be this set right here. Okay. So yeah, just remember that the distance, it's the absolute value of a difference that's the distance between the two parts of that difference. The subtrahend and the minuend, their names for them. Okay, so that makes things a lot easier in some sense, right? Like you don't have to, if you're given something like this, you say, oh, I can either do it algebraically, right? I can either do it algebraically, or I can just think, for this one, it's pretty easy. I can think of this as a distance, right? The distance from x to 2 is less than or equal to 3, right? If I want the distance of x from 2 to be greater than 3, well, that means that I have to stay outside here, right? I have to be more than 3 away, right? And that gives us the other set. Okay. So maybe I won't talk too much more about this. Okay. Yeah. It's just that in tonight's assignment, there's a lot of absolute value stuff. So I want to get it into your heads. Okay. Okay. So there's one really important fact about the absolute value, which is called the triangle inequality. Triangle inequality, and it says this, that if you take the absolute value of a sum, then there's some relation between that and the sums of the absolute values. Okay. There's some relation between the absolute value of a sum and the sum of the absolute values. Can anyone figure it? What is it the same thing? Is the absolute value of a sum the same thing as the sum of the absolute values? No, not always. Right? Sometimes it is, right? If they're both positive, sure, it actually equals the sums of the absolute values, right? What else could happen? If they're both negative, then you get, that's going to be the same thing too, right? Okay, what if one is positive and one is negative? Is it equal? No, it's not, right? What is it? It's going to be actually strictly less than. Right? It'll be less than the sum, right? Okay, so you summarize all these possibilities like this. You say that the absolute value of the sum is always less than or equal to the sum of the absolute values. Okay, and this thing is called the triangle inequality. At least, yeah.
I'm so sorry, what's the bottom one on the far left?
5 plus,
is negative.
yeah, negative, 5 plus negative.
Yes, sorry.
Yeah,
I was
sure,
just
sure. Yeah, in higher dimensions, what this turns out to be is a statement about triangles. That's why it's called the triangle inequality. It turns out to be this sort of statement, that the sum, if you take the length of a sum, this thing is sort of the sum of these two sides. The length of the sum is smaller than the sum of the lengths. Right? In other words, the length of one side of the triangle is always smaller than the sum of the lengths of the other two triangles. two side lengths. Okay, that's why it's called the triangle inequality. In higher dimensions, it turns into this sort of statement. Actually, before I did that, I probably should have given you let you try one example. So let me ask you to do this. Let's say this. Okay. Figure out what this set is. Take 1 minute and figure out what this set is. Okay, who would like to say? Or should I? Okay, first turn to somebody nearby and say, "This is what I got."
This is a process of
Okay, since there's not much time, please somebody tell me what you got.
X is greater than or equal to -1.
Okay, so greater than or equal to negative, x is greater than or equal to -1.
And then X is less than or equal to -7.
Or less than or equal to -7, right? So greater than or equal to -1 or less than or equal to -7. Why? Because this is the distance from -4 has to be bigger than 3, right? So here's -4. The distance has to be bigger than 3, right? So we have to be outside of here, and we have to be outside of here, or we could be outside over here. Okay. Okay. Let me just give you one thing for the homework. One of the homework problems is a little bit tricky, and you'll have to use the following fact that to show A is bigger than B. If A and B are positive numbers, it suffices to show that A squared is bigger than B squared. Okay. Right? If you think about it, right, here is the y equals x squared, right? If you know, suppose A and B are down here, right? If you know that A squared is less than B squared, right? Then you know that A is less than B, right? If A squared is less than B squared, that'll tell you that A is less than B. And vice versa. If A is less than B, then A squared is going to be less than B squared, right, for positive numbers. So there's one problem where it'll be useful to just take the thing you want to show and then square it and then show that thing. Okay, just to give you a hint. Okay, that's it for today.